Hello everyone. Today's question, how to find the most stable resonance structure. For other topics, you will find the playlist link in the description box. Please check that. Okay. So let's start. To find the most stable resonance structures, we have to know some rules based on which we can decide the most stable structure. Fine. So the first rule is the structure with more atoms having complete octet, that will be more stable. And the second point, structure with more number of covalent bonds, that is also more stable. Now you will see in most of the cases these two rules, they go side by side. That is when you will find complete octet in any particular structure. There you will also see that the covalent bonds are also, hence the number of covalent bonds are also high. So we will see one example where we can apply these two rules. Here we have CH3N2 plus. Positive charge is present over this nitrogen, and other resonance structure, if we break any of these, that is one of the bond of this triple bond, then we will get this structure. Now in the first structure, basically octet is complete, that is this rule is satisfied. And if you see the number of covalent bonds, total number of bonds here 4, that is I am just not considering the CH3 bonds because that is common in both. So if you just consider carbon, nitrogen and NN bond, total 4 bonds, and here we have 3 bonds. So that is based on covalent bonds, and if you consider octet, then it is complete in the first structure. How it is complete? See, surrounding this middle nitrogen, if you see how many total number of electrons, it is basically 8 electrons, right? 6 right hand side, 2 left hand side. If you consider the terminal nitrogen right hand side, then also surrounding this nitrogen there are total 8 electrons. And if you consider carbon, where 3 CH bonds are present and 1 CN bond, then also you will see total number of electrons 8. So in this way you can decide whether octet complete or not. But if you look at the second structure, there is no issue with carbon and nitrogen, it is complete. But if you consider this right hand side nitrogen with positive charge, now surrounding this nitrogen total number of electrons 6, it is not 8. So complete is not, octet is not complete. So that is why first structure will be more stable. Come to the next rules. The structure with least charge is more stable. Here you can see in the first structure, which is CH3COCH3, simple acetone molecule. There is no charge, but in the second case, if we break the C double bond O, then we have positive charge over carbon, negative charge over oxygen. Then it will be less stable compared to the first one, because here charge is not present, neutral structure is preferred. And if you also want to consider from the point of view of covalent bond, then also you will see here total number of bonds 4. I am just not considering the CH bond, without that it is 4, but here it is 3. So based on that also you can understand first structure will be more stable. Then structure with negative charge on more electronegative atom and vice versa, that is positive charge on more electropositive atom, that will be more stable, because negative charge is more stable over electronegative atom and vice versa. So in this last example that you are seeing here, CH3 C double bond O CH2 minus, negative charge over carbon. But if we are making a CC double bond here, then negative charge will be over oxygen. So in this case, negative charge is over oxygen, which is more electronegative than carbon. So that is why the first structure will be preferred compared to the other one. Covalent bonds, in both cases it is 4. So here you have to choose based on these rules. Fine. And the structure with least separation of opposite charge is more stable. So example I have not given here, but suppose in one structure there is positive charge, negative charge, and also in the other structure positive charge, negative charge. But if these two opposite charge, if they are very close to each other in one structure compared to the other, then it will be better, because they can stabilize each other. So that is the reason. So here we have different rules, but how to apply all these rules? The rules are to be applied in the order mentioned. So you have to give more importance to the first rule, then you can move down. So suppose in one structure there is, these points are not made, these rules are not maintained, but still you are seeing that octet is fine, that is for all the atoms octet is complete, and also covalent bonds are high. So you have to give more priority, even if it is there is some positive charge over electronegative atom, then also it doesn't matter. So you will find it is very common sometimes for octet completion there is positive charge over oxygen. So don't think that there is positive charge over oxygen, so it will not be stable. So it will be stable if octet is complete. So in this way you have to apply the rules in this order as it is mentioned here. One more point which you will not find, it is not very common where the rules are mentioned in any book, and this is, just see this statement, while comparing elements from different rows in the periodic table. That means period number not same. So suppose one is from second period, another one is from third period, then choose the one where the charge is on the bigger atom, as it is larger and more polarizable. Here we have this example, CH3 is double bond O S minus, but if you are making C double bond S, then C single bond oxygen, and there is negative charge. So in this case this will be more stable because oxygen is from second period and sulfur that is from third period. So that is why you have to give more importance to the bigger atom because it is larger and more polarizable. Similarly, another example, so it is analog type of example, only in place of C double bond O, now we have C double bond NH, but here also the first structure which is carrying negative charge, that will be more stable. Now we will solve some problems based on these rules that we have just seen. Arrange in decreasing order of stability. This molecule is basically formic acid, HCO2H, and 4 different structures you can see here. Now see, the first structure is neutral and rest of the structures they are carrying some charge, so obviously one will be more stable. And if you consider number of covalent bonds, then total number of bonds here 4, and there is also one wedge bond, total 5. Then we have 5 here also. In this case we have 4, here also it is 4. So if we consider number of covalent bonds, you can also consider octet. That is in case of first 2 structure, not only covalent bonds, octet is also complete. But 3 and 4, number of covalent bonds are less, octet is also not complete. So that is why here we will give more importance to 1 and 2, that is these two will be more stable than 3 and 4. And reason I have already said. Then what about in between 1 and 2? 1 will be more stable because there is no charge, it is neutral. So 1 is more stable than 2, and between 3 and 4, here you can see what is the difference between 3 and 4. The difference is here positive charge over carbon, negative charge over oxygen. Here it is opposite, reverse. So obviously 3 will be more stable because negative charge is present over oxygen. Oxygen is more electronegative than carbon. So 3 is preferred. Negative charges, here it is mentioned as in 3 charges are properly placed. So how we will arrange decreasing order of stability? 1 first, then 2, then 3, and then 4. Next problem. Arrange the following resonating structure according to contribution towards resonance hybrid. Now this is another way of saying just arrange it according to stability, because more stable structure it will have more contribution towards resonance hybrid. Here we have CH2N2 diazomethane, right? Now if we see charge in all the structure, there is positive charge and negative charge. What about number of bonds? Here we have total bonds 4. I am just ignoring the CH bonds. Here we have 3, this is 3, this is 4. So A and D, number of covalent bonds high, and you will also see octets are also complete. You can check individual species whether octet is complete or not. Just see this one. Here we have that is surrounding this nitrogen, there is also a lone pair. So total number of 4 electrons are coming from the bonds in the left hand side and 2 electrons lone pair. So total 6 electrons. It is not that octet is complete. Okay. So in this way you can understand in structure B not only 3 covalent bonds, octet is also not complete. And if you consider C, here carbon is positively charged, that means total 2 CH bonds, 1 N positive charge. Total number of electrons 6. Basically carbocation, whenever you will see, there is no octet complete, it is not possible. So that is why B and C, it will be less stable compared to A and D because of this octet completion, or you can say covalent bonds. Now A is more stable than D because negative charge is present over nitrogen in case of the first structure, but in D it is present over carbon. This part is common, so we will not consider it. Negative charge is over nitrogen, so that is why A is more stable than D. And what about B and C? C is more stable than B. Again the same logic, negative charge is present over nitrogen. So based on this, A is greater than D, and then there is C, and then B. So this will be the order. Fine. Next one. Which of the following resonating structures of 1-methoxy-1,3-butadiene is least stable? So here name is given, but in the option structure is also given. So we don't have to consider that, because if you simply draw it, it is 1,3-butadiene. At one position, 3 position there is double bond, and one position there is methoxy group. So see here, total number of carbon 1, 2, 3, 4, and there is a methoxy group. Now look at these structures. Negative charge, positive charge, that is present in all the structures. Next, that is the first thing it appears to us. Next, you can consider the number of bonds. So without CH bonds, if you consider simply CC bond and CO bond, is total 7 here, right? Then in case of the second one also 7. Then here we have 6. This is also 6. So we can say that A and B, it should be more stable, and also just check the octet. Here octet is complete. So in C there is a carbocation, octet is not complete. Here also we have carbocation, octet is not complete. Fine. So A and B more stable, and we have to choose the least stable. Here we don't have to find the order, just choose the least stable. So A and B cannot be the correct option. Now among C and D, how to choose? See, in C and D there is negative charge over carbon, positive charge over carbon. Fine. D also positive charge over carbon, negative charge over carbon. So based on that you cannot do anything. Next point that you can find, in structure D there is heteroatom oxygen with lone pair just beside, that is adjacent to the positive charge of carbon. Now this can stabilize this carbocation by this type of electron donation. Now oxygen is positively charged, so that is why there is this type of stability is possible by the lone pair donation from oxygen, but not possible in case of C. So C should be the least stable. So what are the points based on which we can choose C? A and B more stable than C and D, because in A and B you have complete octet. Then A and B cancelled, they are more stable. Now D is more stable than C because electron deficiency of the carbocation, that means this carbocation is compensated by one electron pair donation from the adjacent oxygen atom. So that is why this should be the least stable structure. So that's all we have today. Thank you for watching. I will meet you in the next video.